A kettle rated 2000 watts contains water at 20 degrees Celsius. The kettle is squeezed on, and after 2 minutes the water starts boiling. Let's take note. After another 6 minutes, 45% of the water in the kettle boils away. Determine the specific latent heat of vaporization of the water. And 2, state one assumption made in your calculation above. Okay, now from the first hour, because from the unit and measurement, in case you have lost track of unit and measurement, just go to the previous videos in the same channel. You will see where I made explanation of this. Contains water at this. So let's write down everything. You know that from specific heat capacity, H is equal to mc delta theta, where H is the heat, M is the mass, C is specific heat capacity of water, and here is the change in temperature. But we know that our H is usually equal to IVT, which is equal to PT. So that means I have to substitute this into this. Put this where I have this. So I'm going to have PT, which is equals to MC delta theta. Okay. Now we are going to be solving it. That means I have to put in the parameters, where P is equal to 2000 watts. The time given for the first case is 2 minutes, which will be converted to seconds. So we will have, which is equals to 2 times 60, and we have 120. Let me just draw my line so that I can solve it over to the other side in case. The specific heat capacity of water is usually 4200. Water to boil, it starts boiling at 100 degrees Celsius. So that means from the equation, it is starting from theta 1 is equal to 20 degrees Celsius and theta 2 is equal to 100 degrees Celsius, because this is the rate at which water start boiling. Because in this case, we are dealing with water, so we use this. So let's proceed. Let's 100 degrees Celsius minus 20 degrees Celsius. We will have 80 degrees Celsius. Let us substitute into the equation. So we now have that PT is equals to MC 2000 from the equation times 120 from this equation. That what we are using already will be equal to M is not given, the mass of the water is not given, times 4280 degrees Celsius. I've already established this already, so I have to just, okay, I believe it's clear. M will be equal to 2000 times 120 seconds all over 4200 times 80 degrees Celsius. If you now play with this and you do your math very well, M will be equivalent to this. If you divide it, you have it in fractions, but I just prefer to keep it in this way. You can check your calculator, and then you have to determine the specific latent heat of vaporization. That is the heat required for. Now I want to go to the second stage. Okay. So during vapor you know that heat gain heat absorb absorb. Okay, so you now see everything very very clearly. Like, all right, let's progress. So know that the heat supplied is equal to heat absorbed. So we know that IVT, we are going to write it equals to, it's always given by this equation for specific heat capacity or specific latent heat of vaporization. So we now know that here we're using the same power rate, 2000 times. In this case, the time given here is 6 minutes. 6 minutes. So if you convert 6, you're going to have 6 times 60 to convert it to second, which is equals to, we are using this mass that we realize from here to put into this. So we have 5/7. Okay, but the question here now says something very interesting before we progress. He said 45 data in the kettle. That means we are looking at 45% of the mass. So we now write here 45 divided by 100 to convert it mass times latent heat of fission. So if we now multiply this, you have 72,000, which is not equal to 5 divided by 100 times the mass times 5 divided by 7 L. I believe this is very clear and elaboratory. Very clear and very elaboratory. So let's progress and move on and see what we are going to be having. 90, we're going to have L will be equal to 28 of vapor. L is now equal to 224,000. Question 2 of it, B, says state one assumption made in your calculation. So the assumption we are to make, I'm going to be making is that it is assumed that no heat was lost to the surrounding. So when you check it carefully, you see that we have been able to solve it systematically. So you check it very well. You see our solving steps. We looked for this and then we got our channel, and then you will enjoy more of these videos. Thank you.